Hey, this is Charlie Thompson, and welcome to the Lab 13B Topographic Maps video. Here are some of the questions that we're trying to answer using topographic maps. Where is it? How far away is it? Which direction is it? How high is it? What kind of landform is it? And how steep is that slope? That's what we're going to be discussing this week. So we found the latitude and longitude of locations, we found the distance between locations, we found the elevations of locations, we found relief, which is the vertical distance between two locations. And this week we're going to find the slope of slopes expressed as a percent and as feet per mile. So last week we found elevations, we found relief, which again is the vertical distance between two locations. And to do that, we used contour lines. So super quick review of the key terms for contour lines. Contour lines connect points with the same elevation. The contour interval is how much higher or lower than a neighbor each line is. And to make a map easier to read, every fifth line is an index contour. The index contour lines are thicker and show the elevation. But remember, every contour line is a contour line. It's just for convenience that the index contour lines are thicker and show the elevation. Each contour line will be higher or lower by the contour interval. So the way we find elevations, if an elevation is on a contour line, the elevation is the same as the contour line. If an elevation is between two contour lines, the elevation is exactly halfway between those two contour lines. So we're going to find the slope as a percent. To do that, you divide the relief, the vertical difference, by the horizontal distance. That number times 100 and then rounded to a whole number equals the slope as a percent. The answer from number 1, relief divided by horizontal distance, multiplied by 5,280 will equal the slope in feet per mile. And we'll go through some examples in this so that you can do it yourself and get used to it. So slope equals rise over run. Slope equals relief divided by horizontal distance. Slope can be expressed as a percent. Slope can be expressed as feet per mile. So let's go through this example. Slope equals rise over run, defined as a percent. You divide the relief, in this case 20 meters, by the horizontal distance, 100 meters. The answer in your calculator would be 0.2 multiplied by 100 is 20%. Defined as feet per mile, we're going to take the number in the calculator and multiply it by the number of feet in a mile, 5,280, to find the answer in feet per mile. So the answer from the calculator, 0.2 times number of feet in a mile, 5,280, equals 1,056 feet per mile. So in this case, the slope, we're only looking at like a 300-foot section of the slope. But if this was a mile long, the vertical difference would be 1,056 feet. So that's how that expression of slope works. So let's look at some examples from Lassen, from the Mount Lassen region. The first one we're going to look at is the Cinder Cone Trail, which goes from Snag Lake, or Butte Lake rather, all the way to the top of the Cinder Cone. So here we've got Butte Lake, and it goes along fairly flat until we get to the Cinder Cone, and then you can see it ramps up. So let's calculate what the average slope is. We're not going to calculate the steepest or the flattest. We're going to look at the average slope for the whole Cinder Cone. So here is that cross-sectional profile. The relief, we're going to use the lowest spot and the highest spot. This is the horizontal distance. So step 1, divide relief, the difference between these two elevations, by the horizontal distance. We're going to take that number, multiply it by 5,280 to get feet per mile. And then the answer in the calculator times 100 is the slope as a percent. So let's go through that. Relief. 6,820 minus 6,060, the relief is 760 feet. The horizontal distance is 8,358 feet. So rise over run gets us 0.0909308,447, which is a really long number. So that's the number in the calculator. If we take that and multiply it by 5,280, that'll tell us the slope per mile. So the number from the calculator, 0.0909308,447 times 5280 gets us a slope of 480 feet per mile. So the answer is 480 feet per mile if the slope is expressed in feet per mile. So we found the slope as a percent, but this is, remember, the raw number in your calculator. To find the slope as a percent, you just take that raw number, multiply it by 100, which gets us to 9.09, which is going to round to a whole number, the nearest whole number, which is going to be 9%. So we found the slope in feet per mile and the slope as percent. Step 2 says don't use the rounded percent. Remember, we found the raw percent and then we found the rounded percent. So the raw number 0.0909308,447 times 5280 gets us a slope of 480 feet per mile. If we had used the rounded number, we would have gotten 0.09 times 5280 is 475 feet per mile, which is off by 5 feet. So if you use the rounded percent, the answer you get is going to be wrong, or could be wrong. So use the raw number from your calculator, multiply it by 5280 to get the slope in feet per mile. Let's look at another example. This is the trail to Brokoff Mountain, going from the road into the park, up this section, and up to the peak. You can see the trail to Brokoff Mountain is much more consistent in its slope. Like, it's almost exactly the same slope the whole time. There's no point on it that it's really much steeper or much flatter. So there's the slope profile. The starting elevation was 660 feet. The ending elevation was 9,180 feet. The horizontal distance is 19,052 feet. So step 1, relief by horizontal distance. Multiply that by 5280 to get slope in feet per mile. And then the answer to number 1 times 100 is the slope as a percent. So relief divided by horizontal distance. Step 1, find the relief. 9180 minus 660 is 2580. So there's our relief. The horizontal distance is 19,052 feet. So rise over run gets us 0.13541885366. We're going to take that number, we're going to multiply it by 5280 to find a slope of 715 feet per mile. So the answer to the slope in feet per mile is 715 feet per mile. So we take the raw number, the relief divided by horizontal distance, 0.1354, multiply that by 100%, which gets us 13.5, which is going to round to 14%. So the answer for the slope to Brokoff Mountain as a percent is 14%. Slope aspect is another question that we're going to be answering in this lab. Slope aspect refers to which direction a slope is facing. Is the slope facing north, south, west, or east? So this Mount Fuji, the black area is facing more or less north. This orange area is facing more or less west. This yellowish area is facing south, and this bluish area is facing east. So if you were standing on this slope, looking out this way, you'd be looking east. If you were standing here, you'd be looking north. If you were standing here, you'd be looking west. You'd be looking south. And slope aspect is really, really important for plants, especially because slope aspect controls how much moisture they get. In the northern hemisphere, south-facing slopes get direct sunlight. South-facing slopes get more direct sunlight. They are drier. They have fewer plants. The north-facing slopes in the northern hemisphere typically get less sunlight, so they have more water and they have more plants. So you can see in this example, this is a northern hemisphere slope. The south-facing slope is getting direct sunlight, so it's hotter, it's sunnier, it's drier, and the south-facing slope is cooler. The north-facing slope is going to be cooler and shady. So let's take a look in Google Earth at an example of how slope aspect can control the amount of vegetation. Okay, so here we are in Google Earth looking at the Pacific Northwest. This area in here, this is Washington State. Down here, this is Oregon. We've got a really good example of the rain shadow effect. That is, the storms come in off the Pacific. They get lifted up by the slope of the Cascadian mountain range. So lots and lots of rain. And then on the other side, there's a really distinctive rain shadow effect. And I was looking one day at this region in Google Earth. So I zoomed in and I realized that I could see drainage patterns. I could see the patterns that streams and rivers were making on the landscape. And I could see that because those areas were more shaded, so they had more vegetation. And then as I looked further, I realized that the slope aspect was determining how much vegetation there was. And so this is a south-facing slope. It's getting direct sunlight. And this is a north-facing slope, and it's shaded. So all of this, north-facing, 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 north-facing. The north-facing slopes are shady, and the south-facing slopes are getting direct sunlight. And so they're drier with much less vegetation. In fact, if we rotate the view so that you're looking at it as if you're the sun, you can see that the south-facing slopes, this landscape looks pretty brown. And if I rotate it around so that we're looking at the north-facing slopes from the same kind of angle, we can see that the north-facing slopes are really well shaded. That pretty much does it for this lab. I wish you good luck on your Lab 13B Topographic Maps lab.